Lesson 9-2, Quadratic Functions. All right, in our first lesson, we really looked at functions, quadratic functions, with either just the ax squared and a little bit more with ax squared plus c. In today's lesson, we're going to add the middle term, ax squared plus bx plus c. All right, so consider the following graphs. Notice that all the parabolas are opened upwards. This is because the coefficient of the x squared term is positive. Had this been a negative, our parabola would open downwards. I just wanted to point that out. All right, so these are all a little bit different because the axis of symmetry, the line that divides the parabola in half, is at all different points. This one's at about 1/2. This one looks like it's at -1. Sorry, this was -1/2. -1, and a little more than -1. The axis of symmetry changes depending on the b value, so it's ever in front of that lone variable. All right, next slide. In order to find the axis of symmetry, there's something you're going to need to memorize. So the axis symmetry, we know, falls on that x-axis. So where is it going to fall on that x-axis? You need to find the x-coordinate. So to do that, x equals -b/2a. This will give us that spot on the x-axis. All right, so for example, if we had y equals 2x squared plus 2, if I wanted to plug this into our formula to see on our graph where our axis of symmetry would be, -b, well this is the b value, oh sorry, there should be an x. Here's the b value, I need to make it negative, so that's going to be -2 over 2 times whatever the a coefficient is, which is 2. This equals -2 over 4, -1/2. So on my x-axis, if this was 1 and this was 2, -1/2 would be where I draw that line of symmetry. If I want to know the point of the vertex, so like where that exact middle is, x equals -1/2. If I put that into my function for my x value, I can find y. So let's do that really quick. Y equals 2 times -1/2 squared plus 2 times -1/2. I think this one has been done already for us. Yep. So when they put it in, looks like they got -1/2 for y as well. So that's how you get the point, the actual ordered pair for the vertex. Second thing to note on this screen is when you have that, let's say that same function, when you substitute x equals 0 into that equation, remember, to find a y-intercept where it crosses the y-axis, you just make x 0. Well, if I put x, say this was a plus c function. If I put x equals 0 into this function, all of this becomes 0, and I just have y equals whatever the c value is. So it's really easy with a quadratic function in this form, y equals ax squared plus bx plus c, to find the y-intercept. It's the c value. Okay, let's do an example together. So they're going to give us something in this standard form of a quadratic function, and we're going to graph it. Looks like we're dealing with y equals x squared minus 6x plus 4. All right, first step is to find the axis of symmetry and the coordinate of that vertex. We need to know this, x equals -b/2a. That is going to give us our axis of symmetry. So putting that in, negative, whatever b is a -6, so -6, that's going to be a +6, over 2 times whatever a is. Here, looks like a is a 1. So this is going to be 6 over 2. X is going to equal 3. Well, that tells us where our axis of symmetry is, but we don't know what point that vertex is. We know that x is 3. What's the y? So if I put 3 into my original function, 3 squared minus 6 times 3 plus 4. 3 squared is 9. 6 times 3 is 18 plus 4. 9 minus 18 is negative 9. Add the 4 is negative 5. So y equals negative 5. This is the point of our vertex. The axis of symmetry runs through x equals 3. So that's one point. We need to remember that point. I'm going to highlight it. All right, doing a little bit more work. Step 2, we need to find two other points that we can graph. The first one that you should think of should always be the y-intercept. That one you just look at whatever c equals. So if I go back into our original function here, and I put 0 in for x's, I'm going to have y equals 4. So my intercept is 4. In other words, 0, 4. So that's another point I can put on my graph. And then if I want one more point, you can just use the substitution method. So I'm just going to pick an x value. Let's see, we have 3, 0. Let's just do 1. What is y when x is 1? So using my same function, let's look at it again. What is y when I make x 1? 1 squared is 1, minus 6 plus 4. Y equals 1 minus 6, negative 5, plus 4, negative 1. So 1, negative 1, that is another point on my graph. So once you have a couple points, step 3, you graph the vertex, 3, negative 5, so they did that right here. We have our y-intercept, 0, up 4, and oh, they found the same point as we did, 1, negative 1. When you have those 3 points, look how easy it is to get our parabola. This point here is 2 away from the axis of symmetry, so I'm going to go 2 more spots, and I have another point. 3 spots away, 3 more spots, I have another point. Then I just connect my points with my parabola, and I have my graph. All right, the last example in this lesson, we talked about a quadratic function for when something is falling from the ground. Well, we're going to change it a little bit in this lesson. If an object was projected into the air, given an initial upward velocity, and it starts a little bit above the ground, we use this formula. That was probably confusing. Let me relate it to a problem. So here we have a basketball game, and during a halftime show, they're going to slingshot a t-shirt into the crowd. So the t-shirt is already starting 5 feet above the ground. That's where they get this plus 5. The negative 16 t squared is just the velocity that this is going to be when it's pulled back and then let go. And the that's the 72. That's the initial velocity. This negative 16 is just part of this formula. So we are looking for how long will it take the t-shirt to reach its maximum height, meaning we need a parabola that goes down. We're looking for the vertex height. What is that maximum height? How long did it take to get there? And what's the range of the function? All right, so in your book it's going to talk about 2 examples. The method 1, the one that we just learned for graphing a quadratic function, and method 2 is using a graphing calculator. I'll let you learn method 2 if you choose to do so. All right, so method 1, first I'm going to, instead of x I have my t, I need to find my vertex or axis of symmetry, which is negative t, over 2a. So if I plug that in, 72, so negative 72 over 2 times negative 16, do the math, I get 2.25. So 2.25 is my t value. That means I'm going to reach my maximum height after 2.25 seconds. This t-shirt will be at its maximum height. How high is that? Well, we're going to get the h value for height. So take h, plug what we just found, negative 16, put 2.25 in, squared, plus 72 times 2.25, add the 5. You end up getting h equals 86 feet. So after 2.25 seconds, the t-shirt is 86 feet high in the air. Then it comes down, and I think it says in the problem that it is caught 35 feet above the court. All right, did we answer all of our questions? Oh, the range. So the possible range for the height of this t-shirt, well, let's put it in the middle. It can't be any less than 5 because they're starting at 5 feet off the ground. It'll never reach 0. So between 5 and our highest point, which is 86, that's the possible range values for the height of our t-shirt. That brings us to our lesson check. Graph all 4 of these functions. Don't forget to find the axis of symmetry with negative b over 2a. And then your vertex, find a couple more points, use the axis of symmetry to bring your points to the other side, and you have your parabola. Good luck.